What is integration? Integration is a method of adding or summing up the part to find the whole. It is a reverse process of differentiation where we reduce the function into parts. This method is used to find the summation on the vast scale. Calculation of small addition problem is an easy task which we can do manually or by using calculator as well. And big addition problems where the limits could reach to even infinity integration method are used. Integration and differentiation both are important parts of calculus. The concept level of these topics is very high. Hence it is introduced to us at higher secondary class and then in engineering or higher education. So this is an example of integration. The symbol of integral is a stylish S. For some, the idea of summing slice. After integral symbol, we put the function we want to find, the integral of called the integrand, and then finish with dx2 means the slice going in the x direction and approach 0 with 0 in width. And here is how we write the answer.
So next is definite integral. Definite integral is defined to be exactly the limit and summation that we look at in the last section to find the net area between a function and the x-axis. Also note that the notation for definite integral is very similar to the notation for an indefinite integral. The reason for this will be apparent eventually. To find the area under a curve between two limits, we divide the area into rectangles and sum them up. The more the number of rectangles, the more accurate the area is. So, we divide the area into an infinite number of rectangles, each with the same very small size, and add all the areas. This is the fundamental theory that lies behind definite integrals. So, the next application to find area is area between a line and a curve. In this explainer, we will learn how to apply integration to find the area between a curve of a function and a horizontal or vertical straight line. Finding the area underneath the curve of a function is a very useful technique that has many applications. For example, finding the area underneath a velocity time graph of an object between 2 points in time give the total distance traveled over the time. This approach works fine then we have a linear function fx, and we can use simple geometry, but it will not work for more complicated function. For instance, if the velocity of an object is not changing at a constant rate, then the velocity time graph will not be a straight line, and we cannot easily find the area this way.
So here is the example question. So the question is, a curve of y is equal to x minus 2 square intersect the straight line of y is equal to x plus 4 at point A and point B. So find the area of the shaded region. So we know that line A and B, the equation is y is equal to x plus 4. So the equation for the curve is y is equal to x minus 2 square. So first thing, if we need to find the area under the curve, we need to find the coordinate of B. Okay, so to find the coordinate of point B, so we need x plus 4 is equal to x minus 2 square. So here we get x is equal to, so here we got x, right? X is equal to 5. So how to find y? So substitute the value of x into the equation of y. So y is equal to 5 plus 4. So y is equal to 9. So the equation of B is the coordinate of B is 5, 9. Okay, so to find the area of the shaded region, here we need the limit of the integral is 0 and 5. So okay, so to find the area of the shaded region, here the limit is 0 to 5. Okay, so here luas kawasan trapezium tu tolakkan dengan luas kawasan under the curve yang tak kena tu. So nanti kita dapat shaded region yang dalam ni. Okay, so integral with limit 0 to 5 x plus 4 minus x square minus 4x plus 4 dx. So we got x square minus so do the differentiation. So x square over 2 plus 4x is minus 2x square over 2 minus 4x square over 2 plus 4x. So with limit 5 and 0. Okay, next selepas memudahkan equation yang tadi tu, kita dapat x kuasa 2 over 2 plus 4x minus x square over 2 minus 2x square plus 4x with limit 5, 0. Okay, so that substitute the limit into the equation. So we get 125 over 6 minus 0. So here we know that the area of the shaded region is 135 over 6 unit square.
So previously my friends already explaining about application of integration to find area, but for this one I'm going to explaining another method which is known as application of integration to find volume. In terms of integration to find volume, there's three different methods then to find area, which is the first one is volume generated when a sector rotated 360 degrees with x-axis, and then the second one volume generated when an area rotated 360 degrees with y-axis, and then the third one is volume generated when an area between a curve and a line rotated. Okay, next I'm going to explaining about a few formulas that I will be using in the integration to find volume, which is the first one is formula on how we are going to find x-axis. The formula is v equals to pi integrate with the limit b and a y square dx equal to pi integrate with the limit b and a, and then we put in a bracket, and then we put down f, and then the second bracket x. For the closing bracket we put the power 2 and dx. So for the next one, I'm going to explaining about another formula that we are going to use to find y-axis. So for this formula, it's kinda the same with the formula to find x-axis, which is you only have to represent different alphabet from the previous one. So for this formula, y-axis is v equals to pi integrate with the limit d and c x square dy equals to pi integrate with the limit with d and c, and then we put down in the bracket for f and then the bracket for y, and then for the closing bracket we put the power and then dy. So this is one of the example question about integration to find volume. Before we answering this question, I'm going to explaining briefly on what we are actually looking for in order to answering this question. So as you can see in this figure, this shape will be produced by taking some function and rotating it in a third spatial dimension around the x-axis. So for the root x in the x-axis from 0 to 1, fill in the area between the curve, and then so we can imagine we are rotating it into 360 degree around the x-axis. So we can see it traces as a three-dimensional shape, and this is called as a solid revolution because we obtain it by revolving a region about a line. So after that, we are going to do some calculation on how we can get this volume for this question. So as this question it said,
the graph of y equals to x squared between x equals 1 and x equals 3 is rotated completely around the x-axis. Find the volume generated. So first of all, we have to write the integrate with limit 3 and 1, pi power 4 and dx. So the question here is on how we can get x power 4. It is because of the first rotating, it will be 180 degrees equals with x squared. Meanwhile, the second rotated, it will be the same, which is 180 degree equals to x squared. So for getting a perfect circle rotated, which is 360 degree, it will same goes to x squared plus x squared, and then the answer will be x power 4. After we integrate it, it will be x power 5 over 5 in the bracket with the limit 3 and 1. To solve this question, another step is we have to put in a calculator, which is 3 power 5 pi equals to 5, and then 1 power 5 pi equals 5, and we will get 48.4 pi. So if we don't get another answer for this one is 142.053. If we didn't get the answer with pi, this answer will be also acceptable because this answer doesn't have pi on it. Lastly, I'm going to talking about conclusion for integration. So my group could concluded that integration is the method of we have figuring the cumulative effect of forces that undergo variation as they act on a body while it's in a motion. Integral enable us to define the cumulative effect of kinetic energy. The application of integration in real life is based upon industry type where the calculus is used. So there's a few of example how integration would be meaningful in our daily life, which is the first one is like in the field of engineering. Engineers use integral to determine the shape of building construction or length of power cable required to connect the two substations. And then the second one, it also used in history where it used to predicting the life of the stone. It also used in the geography, which is used in the study of gases present in the atmosphere. And then the other example, it mainly used in the daily of a pilot to measure the pressure in the air. Shipwreck occurred because of the ship was not where the captain thought it should be. So these are a few of example on how integration could affect and helping our daily life. So I think that's all from our group about integration, and thank you.